So next up, we're happy to welcome Will Uppington, the CEO of TruEra. And I'm looking forward to hearing what TruEra is up to and hearing from Will about how they fit into this whole consumption and development of artificial intelligence and the related buzzword-worthy techniques. Hi, Will.
Hi, how you doing? Can you hear me okay?
Yes, sir.
Oh, excellent, excellent. Okay, great.
The floor is yours, Will.
Okay, great. Well, I think I can build off a little bit off of what Seth was talking about in terms of, as people are starting to adopt machine learning, they're starting to realize that machine learning development is quite a bit different than software development. And that, like software back in the 80s and 90s, there's a real challenge with quality. How can you build in a reasonable amount of time with a reasonable amount of budget machine learning systems that actually deliver on the KPIs? And like we had with software, a lot of the key to that is the ability to test, monitor, and debug the performance, risks, and explainability of AI through the life cycle. So that's what I'm going to be talking about. And I'm going to start with, that machine learning is different from software. And it creates new and unique technical challenges. And these challenges are growing as machine learning is really moving from consumer big tech, the Googles and Facebooks of the world, where it was first used and more broadly, to broader enterprise applications. And the reality is that current machine learning development tools and methodologies are quite immature, and they struggle to produce these high quality ML systems that I was just talking about. And machine learning is experiencing a higher failure rates as a result. There was actually a new Deloitte study that talked about people seeing kind of what they described as middling results on machine learning. And what our contention is that you essentially need a new set of AI quality development tools and methodologies to enable the more successful AI adoption, to get past these kind of middling results and these hiccups as the technology is maturing. So I want to talk a little bit about that. But first, I wanted to make sure there was brought out the relevant aspects of how machine learning works that pertain to this problem. So machine learning, depends on training data and in many situations labels. So here you may have let's say a machine learning model that was designed to differentiate between a convertible and a sports car. And you give it a bunch of images that are labeled as convertible and a bunch of the sports car, and then it automatically learns complex patterns of behavior correlated to those labels, such as like the roof could be correlated to the sports car and not the convertible. And then you take a resulting model that applies patterns to the new data to make predictions. Now, what you see is the key differences here is that because the algorithm is actually building a model and not humans themselves actually coding it, you have a number of differences. And one is that software, you're much more task and completion oriented. Here, this is really about a constant iterative training and experimentation process. It's about building something that's predictive, not necessarily functional. And it's something, because the algorithm is building the model, not a human designing it and building it, it's been known as a black box. So these are key differences. And these differences create unique technical challenges, in addition to the one that you would expect around how do I achieve just good model performance and hit my KPIs. You've got the black box challenge. You've got potential issues in your data where there could be underrepresentative natures or bias in the data. That can also lead to fairness issues. You have the challenge of overfitting or unsoundness, where you build a model in a test environment and it doesn't generalize well to the real world. It's really optimized for the data you've given it. And then there can be situations around not just overall performance, but the reliability across different performance elements. Many businesses, 20% of the customers drive 80% of the profits. So you can have a model that's really good for 100% of your customers, but not good for the ones that are most profitable, and then it's likely not to be successful. And then drift, which is that you've trained it on a certain set of data. If the world changes, then the model performance can start to degrade. And so, with these technical challenges, the context here is that AI is moving from a consumer to enterprise, and where it was used for these kinds of use cases, the movie recommendations and search ranking and things like that, now to more critical outcomes, where if you get something wrong, it's a bigger deal. In particular, you notice that Zillow, for example, was built a home flipping business off of machine learning, and the models ended up not performing, and it led to over $500 million of losses and layoffs. You also say that there's a new set of risks. So you may have heard that when the Apple Card first came out, there was a bunch of allegations that it was biased because men were getting 20 times the credit limit than their wives, even though their wives had higher credit scores. It didn't turn out that to be biased, but in this particular case, but it certainly created an issue, and Goldman Sachs got investigated by the New York regulators and the like. So a whole new set of risks, and both the performance and these risks, like I said before, can change over time. And this is, definitely become more top of mind for everybody, given all the crazy changes that we've been experiencing in the last few years with the pandemic, supply chain, war in Ukraine, etc. In addition to that, regulators are starting to scrutinize these risks. It really is kind of a gathering storm. It started a long time ago, but we've already seen some laws passed. Like in New York City, there's a law requiring audits of AI used in HR. In Colorado, there's a law that's being passed around auditing fairness in insurance. The FTC, CFPB, FDA, all the regulators are updating their guidelines, and the EU, Canada, and Brazil have all proposed AI legislation, a bit like the GDPR of AI. So regulation is coming. It's absolutely a gathering storm. And this is leading to these challenges we talked about, these middling kind of results. So how do you solve these? Our view is that you really need a new approach, which is around AI quality. And that is, how do you evaluate, test, monitor, and debug your machine learning models so you can get the balance between performance and the risk mitigation and regulatory issues that we've just talked about. And so when we talk about AI quality, what do we mean by that? It subsumes these notions of performance and risk and explainability. And what we find is that machine learning teams today have very limited ways to evaluate the quality of the models. So they're typically using global accuracy metrics, where they take a train set that they use to train their models, and they take a separate set of that data to test those models and give you kind of one or a few, accuracy metrics across the entirety of your model. But that's really the tip of the iceberg, because if that's how you're measuring the quality, then you're not going to be able to address those unique challenges of machine learning and all of the issues that we just discussed. You really need much more fine-grained capabilities to evaluate and test quality, such as overfitting, error analysis, conceptual soundness, stability, segment in addition to global performance, the ability to assess fairness and other societal factors, the ability to explain these models so you can make these operationally work with different stakeholders, and that may require collaboration. If you're going to do a predictive maintenance model and you just tell an engineer, go fix this, go replace this component in the machine, and you don't tell them why, well, maybe they don't think that's the right thing to do, and maybe they ignore the result. But if you tell them why and give them a good justification, then you're going to get better kind of results. The challenge is that if this is the kind of more fine-grained way we need to measure quality, current AI methodologies and tools have gaps where they don't have the technology to enable your machine learning teams to make these kind of quality assessments. And it's throughout the life cycle. So in kind of data prep, engineering, and everything you do before you train a model, there's a quality and ethical AI evaluation and debugging gap. This is something where people are using a bunch of open source kind of technologies, and they're doing things in a very ad hoc way right now, not as systematic as software. There's a testing gap where really right now, there's very limited testing actually of performance and risks throughout the life cycle. It's all really based on kind of what one data scientist who's typically building these models is doing largely manually. You don't have necessarily the equivalent of like unit tests and regression tests, which is a clear gap. Explainability. How do you address why the model is doing what it's doing? Does it make sense or not? To get kind of trust and buy-in within your company, but also with the people who are being, the consumers that are being used by the models, and also regulators in many industries. And then there's a monitoring gap. You remember that drift challenge. How do you monitor these? And then how do you, once you identify a potential issue, how do you separate signal from noise and then do an efficient debugging process? Right now, there aren't these technologies to do this, and it's on top of a very waterfall, non-agile kind of approach. And that's partially because of the lack of these. If you look at all on the left, you've got the Datadogs of the world and IDEs and things like that, and CI/CD pipelines that that have been built up to solve these problems in software, and you're just at the very beginning of that in machine learning. So that's what my company does, and other companies, is addressing all of these quality tech gaps throughout the life cycle in both development and production. And we do it by providing a diagnostics capability that's used to explain, evaluate, debug, and improve AI quality during development, a automated testing harness that can be used both during development and production, and then a monitoring system that is there for production environments to supervise, test, and debug models in production. And we have a system that can work across any development, data store, or deployment system. So many companies have heterogeneous environments where the data scientists are using the best tool for the job, and they are, right now, without something that can work across all of these different development environments and data stores and deployment environments, you have to do that with whatever tools that come with that particular development system, which are often, nascent or inadequate, and then potentially your team is having to learn multiple different ways of doing these kind of quality testing, analysis, and monitoring, which really, for most people, doesn't architecturally make sense. You should have some kind of centralized system that can do this across your different different elements of your infrastructure and fit easily into your AI stack. So, kind of what is needed to back up? What are the kind of technologies that are needed to build high quality AI? So it really does start with explainability from our perspective, removing that black box. That not only solves that explainability gap, but the explainability technology gives you the unique capabilities to solve some of these other gaps, which we'll get into. And that has to come with a whole suite of new AI quality evaluation and testing capabilities, the ability to analyze errors, the ability to analyze bias and fairness, analyze to explain these models and understand how conceptually sound they are, how well they're going to generalize, then look at segment level instead of global levels to perform root cause analysis, and reporting. And these are the ones that are needed in order to address these unique challenges that I'd mentioned before about machine learning. So let's do a little bit of showing kind of AI quality in action and what are some of the value you can get from adopting AI quality technologies. So one is in development is you can just build better performing, AI systems. So let me show you a little bit about what are some of the technologies that can enable you to do that. So this is the TruEra interface. We organize into projects. So the project is a particular use case. In this case, I'm going to focus on a model that is being used to assess creditworthiness, whether to give somebody a loan or a credit card. But this can be obviously a million different kinds of applications: churn analysis, predictive maintenance, predicting rare diseases, assessing, whether the pricing of insurance, assessing, scoring an employee as a fit to a particular job. So many different kind of applications. And then within each of these projects, you basically ingest all of your different models. Data scientists build many different models throughout the life cycle. All of these can be put into this kind of project with appropriate documentation. And then what we allow you to do is assess the quality, all of these different elements of quality that we've talked about in the presentation, on each of these models. And you can do it on a single model, and these are kind of some of the summary things, and you can also compare models so that you can look at, for instance, I'm going to add this logistic regression. So I'm comparing a machine learning XGBoost model with a logistic regression model. And you can understand the different elements of quality we've talked about, such as explainability, which are the features that the XGBoost model cares the most, think are most predictive, in this case, grade and annual income, versus the logistic regression that seems to think that the elements of the loan, like the installment rate, the term of the loan, and the grade, are the most important. So let's talk a little bit about how we can help optimize performance. So we're going to go into the performance tab here, and we can measure all different aspects of performance. And one thing we can do is automatically identify high error segments. This is not something that any open source tooling can kind of do. It's a unique TruEra feature, but very helpful because it allows a data scientist to say, okay, I'm always trying to improve my performance. Which are the segments of my model that have the lowest performance? And you can see a variety of them have been suggested: a particular grade of the loan, installment, particular range of debt to income ratio. There was one in particular that I looked at, which was the purpose of the loan, where this was about 10 basis points lower from an accuracy metric. What we do is we give you tools to understand, what could be driving the reasons why, when people apply for these loans with a small business purpose, the model tends to underperform and not do a very good job of assessing risk. And in this case, what we see is that the most important feature for that segment, when people are applying for small business loans, is the purpose feature itself. Now that's a bit unintuitive, and what it means, and it's way more important than all the other purposes that people apply for. And what that generally means is that this model just doesn't have a lot of good features to help make it more discriminatory for predictive for small business loans. Whereas the other purposes, it does a really good job, and thus there are a lot of other features that are important for the other purposes. So that gives you a sense of, okay, one weakness in my model is small business loans. Maybe I don't use it for that right now until I go get a bunch of features to make this model perform a lot better and hit my requirements. Now, that's something that is increasing that kind of performance is something that you can do during development. But one thing you also need to be cognizant of: how well is your model going to generalize? Is it performing in a conceptually sound way? And so we have some automated tools in order to do that as well. So for instance, we can, these are all the different features in the model, and it's showing you how the model is thinking about these features. By the way, this is a user interface that's primarily designed for data scientists, but we have ways to extract this and provide intuitive reporting for non-data scientists as well. So what this is showing is the annual income feature. As your income increases, the model is saying your risk should go down, and that makes a lot of sense. But let's go look at where there may be kind of outliers from these lines, and see how these features do from this outlier perspective, because outliers suggest maybe the model isn't doing the right thing. And you find this annual income feature pops up in here as well. And when you go into this and focus on it, what you see is the reason that it's highlighting this as a potential problem is the model is saying that people with $135,000 of income are actually more risky, all things being equal, than people with $110,000 of income. And so this is not something that was caught in the accuracy metric. And the reason for that is that you actually had the ground truth, though your labels, if you remember, are actually saying that, yeah, the labels we have are saying that these people are riskier because we have more people failing to pay back their loans in this part of the data set. But the reality is that this is a representation issue or a bias issue. because there's just not a lot of data in this area. So it's a small numbers sample selection bias issue, which we've now allowed you to pick up, and giving you the ability to go fix it, or we can go create a bunch of segments around this income so that we can monitor this over time, or do more assessment of what could be causing this and how could we fix it. So that's some of the ways in which AI quality technologies can be used to improve performance. In addition, AI quality technology can provide testing, governance, and responsible AI framework. So that's something that we've worked on with a Fortune 50 insurance company. So we can show a little bit about that. So fairness is something that matters in a lot of different kind of industries. We have the idea here is that in order to make sure that you're not going to potentially create a bias model, that needs to be part of your development process. It needs to be part of your model evaluation process. It needs to be part of your testing process. It needs to be part of your monitoring process. And part of that is because you can't evaluate fairness separately from performance. And so here what we're showing is in this loan model, what's the difference of acceptance rate between men and women? This is one way to measure fairness. We have over 20 ways of measuring fairness within the system. And then if you do have a situation where for some reason you are accepting men at a higher rate than women, we allow you to do the true root cause analysis and debug that. And what we're showing here is that this marital status feature, people are filling out and saying, am I married? Am I married and living with spouse? Is actually the cause. It's generating 60% of that contribution to that bias feature. And in focusing on this, what you realize is that men are filling out their application as married living with spouse at a much higher rate than women. And that's kind of become this proxy variable for gender and is leading to this biased outcome. And we give you the tools from here on out to go and fix this and create this V5 model, which reduces the bias, removes this feature as contributing to the disparity, and does this all while maintaining performance. We've shown a few different ways of, and by the way, we can provide different reporting of this. And all of these different analytics we can also provide doing from a model comparison perspective. So this is that income feature again, and we can show how this model may differ from a logistic regression model. And here in this fairness, we were showing how this model, comparing the fairness of this V1 model versus this V5 model. So very helpful because you're often comparing lots of models during the development process. We've shown in different ways. There's lots more within the ways of analyzing quality, but part of what becomes clear is now, in order to make sure that every time I'm building a new model, I need to be analyzing across all these different dimensions. There's a value to creating automated test suites. So we've done that in this kind of model here, where we've created 31 different test suites around different elements of performance, around different elements of fairness, different elements of stability, which is something we'll get into in a second. And so now you've got a way of making it very easy for your data scientists on an ongoing basis to test and evaluate your models against this during development, but also in other kind of areas. In fact, what we see, and by the way, there's a whole SDK version of this so that you can do this via kind of notebooks as well. And what we kind of see is that people starting to use testing in a variety of different ways in the life cycle. So, to speed up development, to do model validation, to do a different version of A/B testing, evaluation and reporting on live models, and then also on retraining. Very often you're retraining these models, and people right now don't have a lot of tools in order to provide testing for every retrained model. So that's actually a bit of a gap in many life cycles. So if you can create these automated test sets running against all of your retrained model, you're definitely reducing the risk of putting a bad model into production. I'm going to, the next piece is monitoring. So we've helped a bunch of customers provide comprehensive monitoring and then debugging. This is an example of this. You can monitor all those different accuracy metrics that we talked about. You can do it at the global level, and you can also do it at the segment level. So you remember we created all these different income segments, so you can do all your different metrics at that segment level as well. You can do this for not only the outputs, but you can also do it for the inputs, and not just the changes in value, but what we call consequential feature drift, but changes in how those features influence the model themselves. And also in terms of data quality and how to monitor the data quality. And what you quickly find when you put in place monitoring is you start getting potentially a lot of alerts and noise. So what's key is separating the signal from the noise and being able to do debugging. And that's key to any kind of AI quality technology as well. So in here, what we provide is this notion of where anytime you see a kind of a drop, we can examine this in our diagnostics provider to provide a root cause analysis. So we've identified that during this period of time or this quarter, performance was lower by a few basis points. And then we can do this unique true root cause analysis. We're not aware of anybody else being able to do this, where instead of giving you kind of stats of like what happened in this quarter versus your baseline, and then letting people guess, we do this, some specialized math to figure out this contribution to error drifts. And so we say that, well, in that model we had, one of the features was interest rates, this credit risk model, and it's actually that's cause of 37% of this drop in accuracy. And what's happening is interest rates have been increasing. You guys may have noticed this recently. And the model, when it was trained at a low interest rate environment. And now it doesn't perform as well in a higher interest rate environment. And that's actually one of the major contributors to this this kind of drift and drop in performance, and leads to, well, we need to go and probably retrain this model with more data in a high rate interest rate environment, or make some adjustment to our model in order to make it performant. And so I'm gonna wrap up and leave a little bit of time for questions. This essentially, in order to adapt to the unique capabilities of machine learning, new AI quality and the gaps in technology that exist due to the immaturity of these systems, new AI quality technology is needed, and that can lead to improved performance, better trust and lower risk, and operational savings from taking things that may be a manual evaluation or ad hoc evaluation by your data scientist and something that can be automated through these test sets. And that this, really is about also allowing you to move to a machine learning development cycle that's a lot closer to software development and the quality and speed that we know from software development, where we now have the ability to do iterative data quality reviews, build in explainability end-to-end, have comprehensive automated AI quality testing, and then continuous AI quality evaluation and debug once you move it into production, and the ability to take that feedback, do the root cause analysis, and take that feedback in order to inform iterative development. And this was intended more to be about just AI quality in general, but what's different about TruEra is our ability to do this testing, observability, and debugging all in one solution. That's not something that other people do. They're mostly focused on monitoring with some kind of add-on analytics and don't have all of those capabilities in-house. People are generally just kind of productionizing open source technologies. We leverage open source, but we have unique capabilities such as AI explainability that's faster and more accurate than the open source out there. And these unique capabilities you see in us, those root cause analysis, automated error analysis, these are capabilities not available in open source, and a lot of work done to fit this into, let's say you're using AWS SageMaker, we've got some unique integrations to really make it easy to fit into your stack. So that's just a little bit on TruEra, and I'll stop sharing here in case there's kind of time for a few questions. There was some chat here, so maybe I can respond to those. Any guidelines, Ned, or things that I should respond to?
Well, there was some pretty good discussion. I thought that we only have 1 minute. So I think that Matt Schufelt asked one that was, to me, very interesting, which was around bias in the modeling and training of the models in the example that you used around credit scores. But I feel like that's a fairly big topic to ask, and unfair to throw it to you with just a few seconds remaining. So why don't we pause here And just thank you for your time. I really appreciate you coming to present to us today, sir.
Yeah. Just a quick note is that bias kind of just will always exist, and so the question is understanding it and being able to debug it. Bias is what in some ways contributes to the predictive power, but when it's it can also lead to lower performance and also unfair kind of issues. So that's one of the examples why you need these kind of tools to ferret that out and allow your data scientists to optimize for around bias as well as kind of those global accuracy metrics.
Will, thank you very much for your presentation and for your support. We sure appreciate it. I hope you have a wonderful day.
All right, thanks very much.
Thank you, sir.